So good morning everyone, and I'll keep this brief and quick. I think you had a very great first session, the inaugural session. So I don't think I'm going to be telling anything new to you that you didn't listen in the first session about what is important, why Make in Steel Make in Bharat is important, and what are the important things that we need to do. And also probably I'm not going to be telling any fact that you already didn't know, either fact or science. But my effort over the next 5 odd minutes would be to put all of this together to see where we stitch from R&D to the final product and ultimately, of course, to use. And in this case, I'm also very glad about the panelists that are here, because we have people like me from R&D, we have people who are producers, and we have people who are users, and then we have people from the consulting industry who then look at the overall market and the industry, how it happens. And I will begin by thanking Ms. Monica Bachchan and the others who are organizing and who called me over here. And I'm glad that I still was able to make it, because given my commitments, I never really know where I should be at any given point of time. So as everybody knows, the iron and steel is the biggest industry. In fact, in terms of minerals and metals that we mined in 2021, it was 2.8 billion tons. And of the 2.8 billion tons, 2.6 billion tons was iron ore. So as you all know, so the iron and steel is the driver, not just of the country, but of the global economy. And of course, we use it in a different context, but for the purpose here, it simply means that steel drives the overall economy. And very quickly, if you look at a bird's eye view of the steelscape, in spite of steel being used as a single word, there are actually several thousand grades of steel in tonnage production. And we can either classify them in terms of composition and what they contain as plain carbon alloy or stainless steels. You can also classify them in terms of application like automotive, structural, pipeline, steels for aerospace or naval. And there is as a steel practically for any application, right? But the important thing, and this is something that most people do not realize, is that if you go to the worldsteel.org webpage, you will see that more than 75% of the steels, modern steels that we use today, have been developed in the last 20-25 years. Whereas people think that, of course, steel and iron age is there, so steel has been used unintentionally for a very long time, maybe more than a couple of thousand years as well. But when it comes to modern engineered steels, which is what we are talking about now, the thing is we also didn't have only different types of steels that I showed in the previous slide, but you have different product forms and sizes, pipes, tubes, plates, sheets, whatnot. And for all kinds of applications, and since we are sitting in a defense session, I put together the defense things, which are motor casings, naval hulls, and armor and gun barrels, which one of the Mr. Naidu from AVNL will speak about later. And in the first session, Mr. Vinod Gupta spoke so nicely about the Indian Navy and the ships, and which use steel very, very extensively. In fact, the naval construction is the biggest user of specialty steels in defense by a very large margin. And we are happy to say that DMRL has also contributed to the development of those steels, which was then productionized at SAIL and several other plants in the country. So, and this is possible only because of the so-called several phase transformations which are possible in steel. So for the next minute and a half, I'll take your apology, because even though I know this is not a technical conference, but I wanted you to understand the complexity of that and what makes all of this possible and why, because the intention is to move from R&D to product. But I promise you it will not be in depth. So we do have these different phases that we have in steel, and again, I will not talk about it. But more importantly, you can add different alloying elements. This is just a brief on why we have so many different grades of steel and why each one is unique, and why for certain specific applications we need certain special steels. So this is of course what the different alloying elements do, whether it be manganese, molybdenum, silicon, chromium, whatnot. And this is one classic example of, for example, the workhorse 4340 steel, where you can see down at room temperature, you can have a variety of phases in the microstructure, and each of which has very distinct properties. And therefore, for a very particular application and in a particular form, in a thick plate or a thin plate, you might have to do the sequence on the production so that you get exactly what you want. While this offers great flexibility, this also offers chances for making mistakes and errors, right? So moving to the high performance steels in the strategic sector, the typical materials development and evaluation cycle starts with alloy development. And we have ultra high strength steels, which are typically used in aerospace, armor or missiles. And we have high strength low alloy steels, which are used in the naval applications. We then move to alloy production. Then there's processing or fabrication, which is the secondary processing, sometimes it is called as, which is forging or rolling and heat treatment and welding. And of course, we need to characterize, because as you all know, the material development a lot of metallurgy relies on establishing the processing structure property correlations and then using that to do the product. So I'll take two examples very quickly. One is ultra-high strength steels, and again the definition is somewhat arbitrary, depending on somewhere between 1200 to 1500 MPa strength is what are called as ultra-high strength steels, and the applications are where very high loads are applied, and I should emphasize that these are very critical applications such as aircraft landing gear, and you know when a landing gear malfunctions what happens. You don't want that to ever happen, and things like rocket motor casings, and we have our colleague from BrahMos here who will probably talk about it, and then very crucial crankshafts and piston rods, and of course it's also used in armor where ballistic performance. Now converting this into material properties, because this is where the real challenge comes, you will have to balance properties which are typically going one against the other. In this case, for these applications, we will need strength, tensile ductility, and a toughness, which is the ability to absorb energy without breaking, corrosion resistance in many cases, and very importantly also what is called a stress corrosion cracking resistance. So this is where the real challenge comes. And in contrast, again, Mr. Vinod Gupta talked about the ships and the steel for the naval warships. So the requirement for naval steels, if you look at it, again, this is a very challenging domain where they have to operate in very range of temperatures from minus 35 degrees to plus 40 degrees. And things that are used in underwater, sometimes they will be fully submerged, and even in the surface ships, what is below the waterline is always underwater. In saline atmosphere, there are bioorganisms, there is biofouling, and there is wave loading. As you know, the sea can be very rough. You can get storms and hurricanes and so on. In addition, the machinery inside creates a lot of vibrations, heat, and therefore there is both stress and thermal excursions that happen. Because of this, the material needs to have very high so-called brittle fracture resistance under this variation of load and temperature. It needs to be resistant to stress corrosion. Stress corrosion is nothing but corrosion in the presence of stress. That means when you have a load and a corrosive environment like you have in the sea, you do have an environment that promotes stress corrosion. And likewise, therefore, you need resistance to fatigue. Fatigue is basically whenever the loads or temperatures go up and down, then you call that as fatigue. And therefore, you need resistance to stress corrosion cracking and so-called hydrogen embrittlement, which is a very important characteristic for most steels that are used in naval applications. And obviously, when you have to produce a ship, this is one factor that is often overlooked. You can produce very good steels in the laboratory, but when you want to produce a ship, you have to make them in very large sections and you have to make them weldable. So if you make a steel that is not weldable, and there was an embarrassing international incident maybe some 40 years ago where they developed a great steel but eventually found that it was not weldable and therefore it could not be applied, which was for shipbuilding. So you have to start looking at fabrication from the very beginning. And you obviously, like I said, need to make it in very large sizes, and today we make, within the country, we are able to make plates that are several meters long and 3 meters wide. And we are able to make plates which weigh more than 20 tons. A single plate weighing more than 20 tons we are able to make in the country. And it is a testament to what the Indian industry has moved over the last couple of decades. And we are able to make plates that are wider, more than 4 meters in width and more than 50 to 60 millimeters in thickness. Like I said, length exceeding about 15 plus meters. And in terms of properties as opposed to the ultra high strength steel, here you need strength, but you also need very good impact toughness at very low temperatures. In fact, this is the requirement, and I would like to share here that about in the year 2002-2003, at a very high level meeting, it was told that this country can never make the steel, and even if you make it, it will never be cost competitive. And this is the steel that what Mr. Vinod Gupta told today morning, that the country has today produced more than 100,000 tons of that steel, and all the Indian naval ships today use for the last 15 odd years have been using this steel made within the country. So this is again what I talked about earlier, and therefore the material selection is dictated by this, and steels are typical commodities. So just to step back now and look at what are typical strategic sector requirements. The challenges are technical, techno-economic and infrastructure. These are not commercial off-the-shelf steels but customized. They are value added, they are not commodity products. But of course, the demands tend to be very low and not continuous. You have a feast or famine situation most of the time. And like I already said, the naval steels account for the largest by volume and weight of defense products that are used worldwide. And the second is not even close. The second material, whatever is used, is hardly 5 to 8% of the steel usage. And therefore, the other steels, the steels that are not used for defense, the naval construction, the volume requirement you can imagine will be very small. All of these steels tend to be metallurgically very complex, and because of the requirement of very superior properties and combination of properties, you need them to be ultra clean with low sulfur, low phosphorus and low gaseous content. And initially, while this was a challenge, today we are able to produce steels with hydrogen content much lower than 2.5 ppm and sulfur and phosphorus well below what was earlier possible. So this would obviously mean that you need high quality raw materials and you need special melting techniques. I'm sure Dr. Jha will cover something about this in his talk. We need to do ladle refining and degassing, and again we have improved tremendously in the last 10 to 15 years. And you also need special heat treatment facilities and equipment. I would also add a quick bit here about the equipment part that came up in the first session, that steel can be used to make very good equipment, and today we do not make equipment for making steel. We can also make equipment for making other products, defense products, and I think this is one segment that I would urge people attending this conference and even the organizers to take up, that perhaps we should have a future special session focused on manufacturing equipment within the country. That's very, very important because that's one area where we significantly lack. And while providing a market for the steel industry, it will also serve the cause of Atmanirbharta and Viksit Bharat in a very big way. And we ourselves, to the extent possible, are promoting the manufacture of equipment. So this R&D and industry is a very big challenge. And one of the reasons what is so-called value of death is because that several promising products never see the product. And that is because R&D we need new things, whereas industry we need the same repeatability and reliability. And when we have that, we have scalability. Only then we have manufacturing technology, and only when we have the manufacturing technology we have a product. And ensuring product quality, I will not harp on this. This was talked about enough in the first session, but it's very, very important because defense cannot tolerate poor quality. And I think the industry is stepping up, but a lot more industries need to do it, and our processes need to be improved so that we can ensure quality. And it is something that is not an option, it is a mandatory requirement. So how do we convert challenges to opportunities? Is to convert, because defense has low volumes, we need to bridge it to high volume sectors, and we'll have to, I think the manufacturers have a big role here, that you have to think the life cycle cost, educate the consumer, and build business cases for the consumer. Again, it was talked in the morning about defense to railways, the link, because railways is a typical high volume consumer. And how can industry contribute? I believe this would be the one takeaway if you wish to take something. I think there should be a strong internal R&D. The preparedness to deliver demanding products should be high. And skill retention is very, very important because, like I said, the defense requirement is a feast and famine requirement, and therefore you may not have orders for some time. And even if you have a market diversification, you will be able to tide through the lean periods. And quality consciousness, like I already said, both during development and production is very, very important. And obviously, to keep abreast of the latest developments and concepts, technology and infrastructure, and adopt them to the way possible. We should not just think of delivering the product and forgetting it. It's a cradle to component and life cycle support kind of thinking. And whatever policy and strengths today, the government is very supportive and is coming up with many, many different policies, which was again talked about in the inaugural session. And we'll have to use that and identify the individual core strengths within each company and industry to move up the value chain. So thank you very much. And again, sustainability is a very, very important thing that we have to take care of, net carbon and low carbon. Thank you so much.